In Section 3, we focus on Newton's second law. Newton's second law is a formula that tells you that the net force on an object is equal to the mass of the object multiplied by the acceleration. It shows you the relationship between force, mass, and acceleration. So what is the relationship between force, mass, and acceleration? Keep in mind that a force is any push or pull, mass is the amount of stuff in an object, and acceleration is any change in the velocity. It could be an object speeding up or slowing down or changing direction. So what happens when you push an object harder? Or in other words, you give it more force? According to Newton's second law, the more force you have on an object, the more acceleration the object has. The opposite would also be true. If you have less force, there would be less acceleration. What happens when an object has more mass? If the same force is applied to two different objects, but one of the objects has a small mass and the other object has a large mass, the small mass is going to have a greater acceleration. The larger mass will have a smaller acceleration. How do we explain the relationship between force, mass, and acceleration using Newton's second law? What we know so far is that if you have a lot of force, you're going to get a lot of acceleration. If there is a small amount of force, you are going to get a small amount of acceleration. We also know with a big amount of mass, there is a little amount of acceleration. And with a little amount of mass, there is a big amount of acceleration. But the question is, how do we put all of that together to form a relationship between these three pieces? Another way of showing that is in the mathematic equation. Here it explains that we have the same force. We have a person putting the same force on a smaller mass compared to a larger mass. So a ball compared to a truck. And here we see that the person has that amount of force, and a very small mass of the ball gives a great acceleration. Over here we see that the same force on a very large mass gives a very small acceleration. So in mathematic terms, as mass gets bigger, the acceleration gets smaller. There's an inverse relationship. And as mass gets smaller, acceleration gets bigger. Again, there's an inverse relationship between mass and acceleration. Inverse means opposite. So under a constant force, meaning the force stays the same, as mass gets bigger, acceleration will get smaller. Here's one more diagram to show this relationship. In this situation, we have a person pushing an empty cart. Here the cart is empty, and so the cart has a greater acceleration. Here we've added items to the cart, but the push remains the same. The person is pushing with the same amount of force, but because the cart is loaded full of stuff, has more mass, the acceleration goes down, and it is much less. In the third part of the picture, the person is now pushing harder, and so the acceleration has been increased. So if you compare cart 1 at the beginning to the second cart, have the same force, but we've added mass, so the acceleration goes down. From the second cart to the third cart, we've increased the force, but kept the mass the same, and now the cart's acceleration has increased. So to summarize Newton's second law, Acceleration is directly proportional to force. That means if the force goes up, the acceleration goes up. If the force goes down, the acceleration goes down. And acceleration is inversely proportional to mass, which means if mass goes up, acceleration goes down. If mass goes down, acceleration goes up. See if you can answer these questions. If the mass stays the same, but the force is doubled, what happens to the acceleration? And if the force stays the same, but the mass is doubled, what happens to the acceleration? Here, the acceleration would double. Twice the force equals twice the acceleration. But if the force is staying the same and the mass is doubled, the acceleration is divided by half. It goes down by half. You'd have half as much acceleration. This is what Newton's second law really looks like. It's a mathematical equation. Let's put in some numbers to see how it works. Let's say you have a mass of 2 kilograms and you have an acceleration of 5 meters per second What will the net force be? What net force was put on this object to get that acceleration? Well, 2 times 5 is 10. And when you combine kilograms times meters per second, you get a unit called the Newton. And we call it a Newton because it's way easier than saying kilograms times meters per second, or having to write all of that out. Now, what happens if we double the amount of force? So, instead of having 10 newtons of force, we have 20 newtons of force. We still have the same 2 kilograms of mass. What's going to happen to the amount of acceleration? To solve this problem, we take the 20 newtons divided by the 2 kilograms. So we move this over. And 20 divided by 2 is 10 newtons per kilogram. 10 newtons per kilogram is the same as 10 meters per second. That's because a newton means kilograms times meters per second. If we're dividing that by kilograms, like it shows right here, those kilograms cancel out, and you're left with meters per second, which is what we're more familiar with for the units for acceleration. So we doubled the force from 10 newtons to 20 newtons. We ended up with an acceleration that's 10 meters per second compared to 5 meters per second. So we doubled the acceleration. So again, force goes up, acceleration goes up. Now, what happens if we change the mass? Let's go back to our original 10 newtons of force. We had a mass of 2 kilograms. Let's double that to 4 kilograms. How is that going to affect the acceleration? So we will move our 4 kilograms over here. We'll divide the 10 by the 4 kilograms to figure out the rate of acceleration. When we divide 10 by 4, we get an answer of 2.5, and again our units are going to be meters per second because we take kilograms times meters per second, cancel out the kilograms. What happened to the rate of acceleration? We had the same force, but we increased the mass therefore the acceleration is decreased. And in fact, we doubled the mass and we cut the acceleration by half. It was 5, now 2.5 meters per second per second. Remember, Newton's second law is like a good book. It's all about relationships. The relationship between the characters of force, mass, and acceleration.